what kind of triangles have hypotenuse? Right triangles. So this whole idea of what's called hypotenuse leg, and I know that we had that in one of our, we defined it with all the other ways to prove triangles, get side, 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 angle, side, angle, side, angle, 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 side, and then the last one was the hypotenuse leg. Excuse me. Now, what happens here with this thing called hypotenuse leg is obviously, yes, the only way that this works is if you do have a right triangle. Now, when you have a right triangle, every right triangle has to have a right angle. Otherwise, it would be a right triangle. Obviously. Do you guys remember? There we go. Do you guys remember what segment in the triangle is always the hypotenuse? The one across from the right angle. Yeah. It's the longest one, and it's always the one. When we say it, we call it opposite the right angle. Okay. So the right angle always looks at what's called the hypotenuse, which makes the other two sides legs. It doesn't matter what you call them. It is legs. Okay. Now, what hypotenuse leg does is that if you have a set of corresponding hypotenuse and a set of legs, those two triangles can be congruent. Now, this does show that it's angle side side, but we know there's no apps in math. But there is hypotenuse leg. Okay? So the hypotenuse leg thing works. And the reason that it works is pretty easy to show you guys. Excuse me. What's that crazy theorem about right triangles that we tend to talk about from time to time? Pythagorean theorem. What was Pythagorean theorem? Remember? All right. One of those letters is always the hypotenuse. Which one? C. Yep. Okay. So what happens here is you get this. If you have side lengths and you have hypotenuse and stuff, what happens in order for this to work is that the Pythagorean theorem always holds true. Guys, enough. If the Pythagorean theorem didn't work, then it wasn't a right triangle. It's plain and simple how that goes. Now, the reason why hypotenuse leg works is because of this. If I say that the hypotenuse are 10, and we'll say this leg is 8, and that means that one's 8. I can use algebra to solve for the missing side length. You want to go run together, right? So if I say this, a squared plus 8 squared is 10 squared. What's 8 squared? What's 10 squared? 100. So you get this. You get and now it's just basically a two-step problem. First thing you do is subtract the 64, and you get a squared is 36. Well, what's the square root of 36? 6. So that means that since this is a right triangle, that this other leg here would have to equal 6, which means the other leg over here has to equal 6. And as you go through that, as long as you've got two sides of a right triangle, you can always get the third. So hypotenuse leg is kind of like a shortcut from having to use side angle side, or a shortcut from having to use side side side. Because you could show that it works by using Pythagorean theorem, but it will always work because you know two of the parts. The third part has to be the same in order for it to work. That's why we talk about hypotenuse leg. It's just a little bit of a shortcut from one of the others. I don't think you'll see any algebra or anything like that, to be honest with you, with the proofs, or really any in this whole chapter like this one. I figured it was just a real easy way to show you guys why it worked. We do a whole bunch of this stuff second semester with we talk about actual right triangles. It's good times. So might as well just jump right into doing a proof. One of these. There we go. Go ahead and copy it, draw it. Let's walk through it. What's the first thing you're going to write down? Forget it. Okay. Sorry. I'm going to get too fast on top. All right. Angle PRS and angle RPQ are right angles. On your progression sheet, what does it tell you to do once you have right angles? What do you think you can say? Probably already know this, not even look it up. Yeah, exactly. You just say that they're equal to each other, congruent to each other, excuse me. So then you just say angle PRS, congruent, angle R, P, right? Because all right angles are congruent. I know we put that in a box on its own, I think. Otherwise, if you just look at where you have perpendicular, it's kind of using the same thing. Obviously, mark the diagram. In this case, it was already done. And then go to the next given. You guys remember the trick that a lot of times after you write something that's congruent, that usually means you're done with whatever that statement is. Okay? So it's a little trick about that. So go to the next one. SP, QR, and obviously we're marked. Now, one of the things hopefully you start to recognize more and more and more as we've done tons and tons and tons and tons more of these, is that the better you get at marking the diagram, the quicker you'll be able to pick up on which one of the alphabet soup, if you will, ways that you can show it's congruent. Well, a lot of times what I'll tell students is that when you see a right angle, always check to see if it could be hypotenuse-like, but don't always fall back on that it always will be. Okay? So when I look at this, I have the right angles. I have the segment across from which happens to be the hypotenuse. So I check and see, is there any way that I can get one of the legs congruent?
Yeah.
Huh.
PR.
Yeah, PR is reflexive. Okay, it's shared. That shared side, and then you're pretty much done. And then there you go. You get your hypotenuse like that way. So. I know people asking, do you have to write out the word hypotenuse and the word leg? Nope. Absolutely not. Never a dull moment. All right. Excuse me. Whoa, yeah. Again, hopefully by now these aren't too terrible, right? Sir. Oh, did I put an angle? Yeah. Thanks. Let's say you did that on your test. Would I yell at you? No. You did everything else. You just forgot to put it. You put a triangle on one. You put an angle on the other. I knew where you were going. Kind of thing. Sometimes, a lot of times, we get down to those silly, simple mistakes. I usually don't get angry. I mean, I get angry, but not like I'm going to yell at you. Let's do another. This one didn't show up as well. So it has a segment bisector thrown in it. And I want to do just change this up. Instead of the triangles, I'll make a C. Who did I get that away? And this one has some good progressions to it, like we've done in class, we've done on homework, we've done on the quiz. Quite honestly, I really don't think there's really any type of a scenario that you guys haven't seen yet. Yeah. I think we've done examples just about every single possible thing that we can do. I think there's anything else. No, I wouldn't say that far. I wouldn't go that far yet. I mean, I still have examples now, so don't worry. We're getting there. You should be getting good at this by now. If it makes you feel better, if it makes you feel any better, this should only be about another week. So what does the segment bisector do? Bisects the segment, right? Excuse me. So what segment's being bisected? Which one? AD, yeah. Now, a lot of times, you gotta be, it doesn't say that AD bisected BE, it just says BE bisects AD. So a lot of times, sometimes people will mix up the letters and do the wrong part. So just be careful when you read it of how it goes through. So, let's see. BE So when I go to my diagram, I mark it up so that way I know which ones are going to be right, or not right, excuse me, right. And obviously you got to say that it's a segment bisector, not an angle bisector, because it's a segment, not an angle. And again, we got to the point where we'll notice that you said something was congruent. As soon as you say something that's congruent, usually a giveaway that you're done with that bit. So you go to the next one. You're perpendicular. What happens when you're perpendicular? Well, on our progression sheet, it always said to go ahead and state the right angles that are formed. Well, in this case, for this first perpendicular, there's only going to be one right angle. Please still write it down. Can I use one letter for it? Yeah. This case I can use one letter because, excuse me, angle B is the only vertex there, so that's okay. If you write it out with 3 letters, it's fine. I'm going to say angle B. I can't say that it's congruent to anything because I only have one angle right now, so I have to do the next bunch and say I have another one. That one was what, DE and EC? DE perpendicular to EC. The right angle that's formed there is E. Do I now have 2 right angles that are on my sheet? Yeah. Now I can say they're congruent. You just have to label. The way that this one works is that I think we've done one like this before, where you have to label them out before you can say them. So now I can just go ahead and say B and E are congruent to each other. What do you think the reason is? Good. Yep. So just from this much here, I mean, right away, that's 7 steps. And every one of them on there came off the progression sheet. Didn't have to worry about thinking, really. Okay. What else is up there? A, B. Okay. So mark it. Do you have congruent triangles? Yeah, you can go and say you have hypotenuse leg. This is also an example that if you wanted to and you forgot that hypotenuse leg was a thing, you could have gotten those 2 angles congruent because of why? Vertical. I could have gotten vertical there, and then I could have had angle, angle, side. That would have worked. That's a thing. So there's a couple different ways to go about these things. Excuse me. So let's see, we have triangle. ABC. If I say ABC, what do the other letters have to match up to be? Yeah, DEC. Oops. And once you have congruent triangles, what can you say about all their corresponding parts? And I think I wrote A and D, correct?
Yeah.
And again, it's kind of the same thing over and over and over again. Really, you only had to kind of figure out how are you going to show the triangle congruent. It's really the only thing in that whole proof you had to do on your own. Everything else was kind of written out for you. Okay? Hopefully, those 3.5 days off of this, they can completely go. Okay. Go for it. Do that one.